Welcome back, dear listener, to another journey through the wonders of science, a bedtime story made to soothe your mind while sparking your curiosity. In our first adventure, we explored could we cure inherited diseases forever, tracing the secrets of genes and the possibilities of healing our deepest roots. Tonight, we invite you to drift into our second story, Black Holes. Could they be cosmic gateways? Here you will sail past stars and into the darkest mysteries of the universe, carried by gentle words and real science. Close your eyes, breathe slowly, and let your mind float among galaxies. This story is here to comfort you, to inspire you, and to remind you that even the night sky is filled with wonders waiting to be discovered. You lie back beneath the night sky, your chest rising and falling with the quiet rhythm of your breath. Above you, darkness spreads out like an endless velvet cloth, soft and silent, pinpricked with cold diamonds of starlight. The more you look, the deeper it feels, a living canvas of shadows and shimmer, each star a whisper of ancient light. You notice how the sky seems to breathe with you. Constellations drift across the heavens like slow ships on a black ocean. Between the stars there are places where the darkness grows deeper, as if something unseen tugs the very fabric of space inward. These darker patches are not empty, but doors to mysteries, hints of secrets hidden beyond what eyes can see. As you gaze, your mind drifts across the expanse of time itself. Some of the starlight falling onto your eyes tonight left its home thousands, millions, even billions of years ago. Each glimmer is a message from the past, a cosmic postcard carrying news of distant suns. Yet there are also places where even starlight cannot escape. These are the black holes, scattered through the universe like silent punctuation marks in the story of existence. You begin to sense that the night sky is more than a decoration above you. It is a record of births and deaths, of explosions more powerful than words can hold. A star's light is not forever. Stars age and die, and when the biggest ones reach their ends, they collapse in a final act so intense that they punch holes in space-time itself. These holes are not cracks or flaws, they are black holes, dense, hungry, and endlessly patient. Tonight you wonder how such darkness can come from light. You imagine the life of a massive star, how it burns with blinding brilliance, forging elements in its fiery heart, creating the seeds of planets and life. But when it runs out of fuel, its core collapses. The star's outer layers burst outward in a supernova so bright it can outshine entire galaxies. In its dying breath, the core shrinks beyond imagining, folding space like cloth pulled into a knot. In that knot, gravity grows so strong that nothing can escape, not light, not time, not even the smallest whisper of radiation. You trace these thoughts like constellations in your mind, connecting them with lines of the quiet curiosity. The black hole becomes more than a dark object. It becomes a reminder of the universe's extremes, of how life's brightest lights can end in the deepest shadows. As you imagine drifting closer to a black hole, you sense how space itself bends and curves. If the universe were a trampoline, a black hole would be like a heavy marble pressed deep into its center, warping the surface so steeply that anything nearby slides inward faster and faster, with no way to climb back out. This bending is not just a picture, it is the reality of gravity. It is the reason black holes are the ultimate sculptors of their surroundings, shaping orbits and swallowing matter that strays too near. You close your eyes and feel the slow pulse of the cosmos around you. Galaxies spin like cosmic whirlpools, each harboring a black hole at its heart. Stars orbit these invisible centers in elaborate dances, following curves carved by gravity. Gas clouds drift in, glowing as they spiral down and heat up, releasing X-rays in their final screams of light before crossing the black hole's hidden edge. This hidden edge is called the event horizon, a boundary so quiet, so absolute that nothing crossing it can ever return. Yet from afar, black holes reveal themselves by what they do to their surroundings, by the way they bend starlight, by the ripples of gravity they send across the universe when they collide, by the flickering signals of matter falling in. You think of how strange it is that some of the universe's brightest displays come from the darkness of black holes. Quasars, beacons brighter than entire galaxies, are powered by supermassive black holes consuming gas at their centers. As matter falls in, it heats to temperatures beyond imagination, blazing with a radiance that can reach across billions of light years. The thought comforts you that darkness and light are not enemies but partners, shaping each other in an endless dance. Without black holes, galaxies might not form as we see them. Stars might not gather in elegant spirals. The universe might lack the structures that give it beauty and order. You breathe in the night's cool air, feeling small but not insignificant. You realize that by looking up, you are part of something vast, a universe that has been evolving for nearly 14 billion years, full of stories written in light and shadow. In this moment, the cosmos does not seem cold or indifferent. It feels like a slow, patient heartbeat, inviting you to rest your worries and float on thoughts of stars and space. The darkness above you is not empty but alive with possibility, with questions waiting to be asked. Could black holes be more than endings? Could they be bridges, tunnels, or even gateways to other realms? Your mind hovers on this question, soft and curious. You feel yourself drifting along the velvet veil of the cosmos, where each star and shadow leads you further into wonder. Ahead lies the story of how black holes are born, of how the universe recycles its brightest giants into the darkest abysses. As you begin to slip towards sleep, a thought lingers like a final star at dawn. Every ending has a beginning hidden within it, waiting to be seen by those who dare to look deeper. You drift in the velvet darkness you explored before, still feeling the hush of starlight on your skin. The night sky stretches on forever, yet your thoughts narrow to a single, massive star. A star so bright and heavy it outshines thousands of suns. This star has been burning for millions of years, its heart a furnace where elements are born. You hover here, patient as the star's own light, and watch the delicate balance between creation and collapse unfold. In the core of this colossal star, nuclear fusion is both an artist and a warrior. Hydrogen fuses into helium, releasing light and heat that push outward against gravity's constant pull. This tension is the star's heartbeat. Gravity pressing in, fusion pressing out, a cosmic tug-of-war that keeps the star alive. It is here in the star's hot, dense center that elements essential for life, carbon, oxygen, nitrogen, are forged in tiny blazing collisions. You sense the beauty of this invisible forge, but you also feel a growing exhaustion in the star's rhythm. Fuel burns away, slowly at first, then faster. The star swells into a red giant, its outer layers ballooning outward, its light flickering with age. Helium fuses into carbon, carbon into neon, neon into heavier and heavier elements, a ladder of fusion that climbs ever closer to its final rung. Each fusion step feeds the star's brightness, but every step also brings it closer to an end. As you float near this swollen giant, you see the star's light shifting to a deeper red, like sunset colors trapped in a single enormous flame. Its outer layers shimmer and pulse, but inside the core grows heavier. Iron begins to form, but unlike lighter elements, iron does not release energy when it fuses, it only absorbs it. This is the quiet, invisible moment of doom. The star's heart grows cold, heavy, and hopeless, unable to push back against gravity any longer. Then it happens, a collapse faster than thought. The core's mass crushes inward in a heartbeat, squeezing atoms into an unimaginably dense knot. The outer layers, no longer supported, rush inward too, then rebound outward in a titanic shockwave. In that instant, a supernova is born. You watch in slow motion as the star erupts, brighter than entire galaxies, blasting its outer layers into space at thousands of kilometers per second. The explosion is both terrifying and beautiful. Elements forged over millions of years are hurled across the cosmos. Carbon for future trees, calcium for future bones, iron for future blood. The star's death writes the next chapter of life into the universe, even as it creates something entirely new at its center, a black hole. You drift closer to this newly born abyss. The core, once the star's beating heart, has collapsed into a singularity, a point so dense and small that space-time folds around it like cloth pulled tight. Gravity here is absolute. Light itself cannot escape once it crosses a boundary called the event horizon. The black hole does not shine. It waits in perfect darkness, silent and patient, like the pause at the end of a long, beautiful song. Around it, the remnants of the supernova swirl and glow. A disk of gas and dust spirals into the black hole, heating to millions of degrees. This accretion disk flickers with X-rays, the final scream of matter falling beyond the point of no return. You can almost hear the hiss of friction as atoms collide, releasing their last light before crossing into the eternal night. You imagine hovering above this maelstrom. Space and time are twisted here. If you could shine a flashlight sideways, you'd watch its beam curve back toward you, trapped by the black hole's gravity. Time itself stretches near the event horizon. A clock falling towards the black hole would seem to tick slower and slower, freezing at the edge in the eyes of a distant observer. But for anything crossing that boundary, time flows on, rushing toward the singularity in a final unstoppable plunge. You sense the immense difference between a star's vibrant life and the cold permanence of a black hole. The transformation is absolute, yet the two are connected, one born from the other. A black hole is the ultimate expression of gravity's power, formed from the very light that once illuminated galaxies. You drift farther into thought, picturing many black holes born from stars across the universe. Some are just a few times the mass of the Sun, formed from massive but ordinary stars. Others forming clusters of massive stars, each death adding to the population of black holes scattered like seeds across the cosmos. Each one is a silent monument to a star's final act. Your mind wanders to even larger possibilities. Could black holes merge? Could two dark hearts spiral together, colliding in a final dance that sends ripples of gravity through the universe? The answer, you learn, is yes. Black holes can find each other in the crowded hearts of star clusters or the dense centers of galaxies. When they merge, they release gravitational waves, ripples in space-time itself, like stone dropped into a cosmic pond. These gravitational waves, first detected by human instruments in 2010, are the quiet song of black holes. They carry news of distant cataclysms to Earth, letting us hear the collisions of black holes billions of light years away. You realize black holes, though silent to our eyes, mag through the language of gravity, whispering stories of cosmic violence and ancient stars. As you drift over this newborn black hole, you remember that nothing here is truly wasted. The supernova's explosion spreads elements into space, enriching future gas clouds that will birth new stars and planets. The black hole itself shapes its surroundings, pulling on nearby stars, sculpting orbits, and setting the pace of cosmic evolution. You begin to see black holes not just as destroyers, but as sculptors of the universe. Without them, galaxies might never form the way they do. Their gravity helps gather stars, keeps clusters bound, and stirs the gas that seeds new suns. In the grand cycle of birth and death, black holes are both endings and beginnings. You begin to see black holes not just as destroyers, but as sculptors of the universe. Without them, galaxies might never form the way they do. Their gravity helps gather stars, keeps clusters bound, and stirs the gas that seeds new suns. In the grand cycle of birth and death, black holes are both endings and beginnings. You let these thoughts settle, feeling your breath slow as your mind expands. The universe feels like a place of balance, where even the most violent acts have purpose, where destruction feeds creation and darkness gives shape to light. You realize that in the birth of a black hole, you witness the universe's power to transform itself, endlessly, beautifully. As you float in the darkness, you notice the subtle pull of gravity everywhere. You think of the strange and wonderful dance gravity choreographs around every black hole, stars bending in long ellipses, gas swirling in shining disks, space-time warping in invisible ripples. Your heart grows quiet with the realization that everything you are, every atom in your body, came from stars that lived and died like this. You are not separate from the cosmos. You are made of its ancient stories, woven from its light and darkness. Your eyes flutter closed as you drift towards sleep. The universe seems to exhale, and you feel yourself carried on that breath deeper into the mysteries of space. Ahead lies the question of what happens next, how gravity continues its dark dance around black holes, how their pull shapes the fates of stars and time itself. You drift in the gentle hush left behind by the birth of a black hole. The supernova's roar has faded, but in the silence that follows, you feel something deeper, a quiet force reaching across space. It is gravity, subtle, yet unyielding, patient as time itself. You realize this pull is the black hole's first language, whispering to the universe around it, bending reality with every breath. The stars near the black hole forwards to feel it first. Their orbits shift, slowly drawing them closer in elongated, graceful loops. You imagine these stars as dancers tracing careful steps around an unseen partner, their light shimmering like silk ribbons as they swing near and then arc away. Gravity shapes these motions, choreographing an endless ballet that can last millions of years. As you watch, you notice how space itself curves near the black hole. If the universe were a sheet of fabric, the black hole would press down so deeply that anything straying too close slides inward, drawn along the curves of space-time like a marble rolling into a funnel. The closer you drift, the steeper these curves become. Gravity grows stronger, and the rules of distance, time and light begin to blur. You hover in this warp space, letting your mind sink into the idea that gravity is not just a force pulling things together, it is the bending of space and time themselves. Near the black hole, this warping becomes extreme. Light passing by is bent in arcs, creating the illusion of distorted, looping images. Stars behind the black hole appear to split and circle it like a halo, their light curving around the dark heart at the center. You imagine shining a flashlight across the black hole's face. Instead of a straight beam, your light bends sharply, some of it swinging into orbit before escaping, some spiraling inward, beyond the event horizon. This bending of light is called gravitational lensing, and it makes black holes both invisible and strangely visible. Though they emit no light of their own, they reveal themselves by how they twist the light of everything around them. Your mind drifts to time itself. You remember how clocks near a black hole run slower than those far away. This time dilation is not a trick of perception, but a real effect predicted by Einstein's theory of general relativity. If you floated just above the event horizon, hours for you might pass while years raced by elsewhere in the universe. Time near a black hole is like syrup, thick and so, stretching moments into eternities. This slow dance of time is more than a curiosity. It shapes the fate of everything caught in the black hole's gravity. Stars that stray too close are pulled apart in a process called spaghettification, where gravity's pull grows so much stronger over small distances that the star stretches into a thin stream of glowing gas. You picture this gas spiraling inward, heating up and releasing bursts of X-rays as it crosses the point of no return. Yet there is a quiet beauty in this violence. The star's light, torn into worn threads, wraps around the black hole in brilliant curves before fading forever. Even in destruction, gravity creates patterns, spirals, arcs, and flares of light that dance in the darkness. You shift your gaze to stray particles, dust grains, drifting gas, even lone photons wandering too near. Nothing escapes the black hole's silent persuasion. Even light, the fastest traveler in the universe, bends and wavers, its path curved by the black hole's warping of space. You imagine photons skimming close, some pulled in, others slingshot away in wild, twisted paths. In your mind, you trace the accretion disk that often forms around a hungry black hole. This swirling disk of hot, glowing gas marks the region where matter spirals inward, friction heating it to millions of degrees. The inner edge of the disk, closest to the event horizon, glows brightest, flashing with X-rays that signal the black hole's feast. This light can outshine entire galaxies, even though it comes from gas only moments from oblivion. As you drift above this swirling light, you sense how gravity sculpts not just space, but the flow of matter itself. Black holes are like cosmic potters, shaping disks, jets, and streams of gas into breathtaking forms. In some cases, black holes launch powerful jets of particles at nearly the speed of light, shooting out along their poles in twin beams that stretch for thousands of light years. These jets stir the gas in galaxies, regulating star formation and influencing the evolution of entire clusters. You marvel at how something so small, a singularity only a few kilometers across, can have such profound influence on structures millions of light years wide. Gravity's silent pull extends far beyond what eyes can see, shaping cosmic architecture, from the scale of stars to the scale of superclusters. Your thoughts wander to the center of our own galaxy, the Milky Way, where a supermassive black hole called Sagittarius A waits in the darkness. Millions of stars orbit this hidden giant, some moving at incredible speeds as they whip around its invisible mass. Observations of these orbits provided the first direct evidence of a supermassive black hole, proving that our home galaxy, like so many others, is anchored by a dark, massive heart. You imagine yourself drifting near Sagittarius A, feeling the slow tug of its gravity, watching stars speed by like fireflies in a black wind. Despite its mass, 4 million times that of the Sun, this black hole remains quiet most of the time, feeding only occasionally when gas drifts too close. Its pull is always there, a patient sculptor tour of the galactic center. You realize that every black hole, big or small, is defined by the same irresistible pull. Whether born from a dying star or formed from the collisions of ancient giants, each black hole reshapes its surroundings through gravity's delicate yet unstoppable embrace. The silent pull of a black hole is the universe's reminder that nothing exists in isolation. Everything is connected by the quiet bonds of gravity. Your breath slows as you float on these thoughts. You picture gravity not as a harsh jailer, but as a cosmic guide, bringing stars together, curving paths, and weaving the invisible web that binds the universe. Even the Earth beneath you, though far from any black hole, dances to gravity's tune as it circles the Sun, which in turn orbits the Milky Way's center. In the hush of your imagination, you let yourself feel the soft power of gravity in your own life, the weight of your body resting on your bed, the gentle tug of Earth holding you close, the shared bond that keeps oceans hugging the shores, the moon circling overhead. Gravity is not distant or abstract. It is here with you, constant and kind. You sense the slow rhythm of time stretching near the event horizon, the whisper of light curving around Deacon's darkness, the patient pull of matter toward the heart of a black hole. The more you drift in these thoughts, the more you see how gravity's silent dance sculpts not only black holes, but the galaxies, stars, and planets that make up the universe, including the one you call home. As your eyes grow heavy, you wonder what mysteries lie deeper still. If black holes can pull light and time into themselves, what happens inside? What secrets might be hidden beyond the event horizon, waiting for those brave enough to imagine them? These questions linger in the quiet as you drift toward dreams. You drift through the quiet left behind by gravity's dark dance. Stars still circle their silent partner, light still bends in graceful arcs, and time still flows, though not as it once did. You feel the black hole's pull growing stronger as you float closer, the velvet night deepening into a darkness so complete it feels almost warm. You are approaching the event horizon, the black hole's boundary, where physics begins to unravel and time itself changes its meaning. In the distance you see light from stars and glowing gas warped into circles of brilliance. As you near the black hole, these rings of light grow sharper and stranger, bending into halos that wrap around darkness like a crown. These shimmering arcs are not tricks of your eyes, but the last images of matter and light before they vanish beyond the event horizon. You hover at this invisible boundary, knowing it marks the point of no return. From outside, the event horizon appears frozen in time. Anything falling inward seems to slow, creeping ever closer to the edge without quite crossing it. To a distant observer, time at the event horizon stands still, seconds stretching into centuries, moments lingering forever. Yet for anything falling in, time flows on as usual, carrying it past the horizon and into the black hole's heart. You let your mind rest in this paradox, feeling how time and perspective twist near the event horizon. You remember Einstein's insight that gravity is not just a force, but the bending of space-time itself. Near the black hole, space-time stretches so dramatically that time runs slower for you than it does for the stars far away. Minutes for you could mean millennia in the outside universe. This slowing of time is not merely a theory. It has been tested near massive objects like Earth and our Sun, though the effects there are subtle. But near a black hole, time dilates so powerfully that it becomes a chasm between you and the universe beyond. You imagine floating here, watching the cosmos race forward, stars aging, and galaxies spinning through eons while your own heartbeat continues in quiet rhythm. You sense how this stretching of time creates a gentle silence, as if reality itself holds its breath at the brink of the event horizon. Light, falling inward, grows redder, shifting to longer wavelengths until it fades into invisibility. Even sound, if it could exist in the vacuum of space, would stretch into deeper and deeper tones before vanishing beyond the edge. As you drift along this boundary, you realize the event horizon is not a solid surface, but a limit defined by the speed of light. Once something crosses it, even light itself cannot escape. It is a one-way membrane. Crossing it is crossing into the unknown. The black hole's mass determines the size of its event horizon. A stellar mass black hole might have an event horizon just a few kilometers across, while a supermassive black hole's horizon can span billions of kilometers. You imagine reaching out a hand, feeling nothing but the void as you cross this threshold. There is no wall, no sudden change you could feel. Yet crossing the event horizon seals your fate. No path exists that leads back out. The fabric of space-time curves inward so completely that every direction, even the one you think points away, now leads deeper into the black hole. You think of photons, particles of light, skimming just outside the event horizon, caught in orbits called the photon sphere. Here, light circles the black hole again and again, trapped in a perfect, endless loop until it either escapes outward or spirals inward. You picture beams of light tangled like threads of gold around a sphere of darkness, the last visible echoes of the universe's brilliance before it surrenders to shadow. You breathe slowly as you absorb these thoughts, letting the strange beauty of the event horizon settle in your mind. You realize how it marks the boundary between the knowable and the unknowable, the line where physics as we understand it ends and mystery begins. Beyond this veil lies a realm where matter, energy, and even the flow of time may follow rules we cannot yet imagine. As you float, you think about what would happen if you crossed the event horizon. Depending on the size of the black hole, you might feel nothing at first. In the case of a supermassive black hole, the tidal forces at the event horizon could be gentle enough that you would pass the threshold unaware. But in smaller black holes, gravity's gradient grows fierce, stretching you into a thin line in a process called spaghettification, where your head and feet experience such different pulls that your body elongates like a noodle of starlight. You sense the danger but also the wonder of such a journey, that even in the violence of gravity's extremes, there is a profound elegance. The event horizon becomes a threshold not just of space but of understanding. Here, light, time, and matter weave together in a tapestry of paradoxes that challenge everything you know. Your mind drifts back to the first images humans captured of a black hole's event horizon, the famous ring of light around the supermassive black hole in the galaxy M87. This orange halo, glowing in radio waves, revealed the shadow of the event horizon for the first time. It showed us that black holes are not only real, but that their event horizons cast a silhouette on the light they bend. That image made the invisible visible, proving what theory had long predicted. You think of the future, of telescopes more powerful than any today, watching the event horizons of black holes as they grow, merge, and send gravitational waves whispering across the universe. You imagine the stories we will tell as we learn more, stories of time frozen and light trapped, of the quiet majesty of the event horizon. As you float at the brink, you let the hush of this place seep into you. The event horizon feels like the quiet center of a storm, a place of perfect stillness surrounded by swirling chaos. Outside, matter may rage in disks of X-ray fire. Inside, all roads lead inward. This silence is not empty, but full of possibility, a place where the rules of the cosmos pause before diving into mystery. You breathe in the thought that time itself is flexible, that seconds and centuries can trade places depending on where you stand. You realize that the universe is not static, but alive with these shifting rhythms, with spaces where time stretches like taffy and moments can linger forever. As your eyes grow heavy, you wonder what lies beyond the event horizon. What becomes of matter and light that cross this quiet boundary? Do they simply fall into darkness, or could they reach another place, another time, another universe? These questions swirl like stardust in your mind as you drift, warm and weightless, on the edge of sleep. You hover at the silent edge of the event horizon, the line where time pauses and light clings to the last threads of escape. In the quiet of your thoughts, you lean forward and imagine yourself slipping past this invisible boundary, crossing the threshold into the black hole's heart. There is no flash or sudden rush, only the gentle, absolute surrender to gravity's embrace as you fall forever into the night. At first, nothing seems different. The stars behind you stretch and fade, their light shifting redder and dimmer as you sink deeper. You feel time unraveling, not in jolts or jumps, but in a slow, patient distortion. Every heartbeat becomes a lifetime beyond the horizon. Every blink out there sees eons pass while you drift in perfect calm. Space and time twist together like a spiral staircase of shadows, drawing you down into the black hole's depths. You imagine yourself floating free, your body untouched by friction, your mind aware of the smooth darkness around you. The laws of physics you once trusted become strange companions. Directions lose meaning, distances warp, and the familiar sense of up and down dissolves. Here inside the event horizon, every path you can take, every possibility, leads only inward. As you sink, you think of the singularity waiting ahead. It is not a place you can see or touch, but a point of infinite density where space-time ends. In a stellar mass black hole, you would reach the singularity in seconds or minutes. In a supermassive black hole, your fall could last hours, days, or longer. Yet from outside, your final moments appear frozen at the event horizon, your image lingering like a ghost in the darkness. You imagine light itself falling with you. Photons born alongside you slip deeper into curved space-time, stretching into longer and longer wavelengths until they fade entirely. These last traces of brightness remind you how the black hole drinks not only matter, but light, swallowing every story, every reflection, every glimpse of the universe beyond. The further you fall, the more you feel the pull of tidal forces. If you approach a small black hole, gravity's grip tightens fiercely across your body. Your feet feel a stronger pull than your head, stretching you thin like a strand of light. This spaghettification, both eerie and beautiful, is gravity's way of expressing the sharpness of space-time's curvature. Yet in a supermassive black hole, the journey is gentler. Tidal forces remain small at the horizon, letting you drift unbroken into the darkness, carried on gravity's quiet river. You imagine the singularity as a distant dark star drawing you in, a place where the very fabric of reality buckles and collapses. Your fall becomes a journey not just through space, but through the edges of understanding itself. Time grows more fluid as you drift. Every moment feels both eternal and fleeting. Outside, stars continue their orbits, galaxies swirl and the universe evolves. Inside, your seconds stretch into infinity, giving you space to think, to dream, to wonder. You reflect on how black holes do not simply end things, they transform them, taking matter and energy and hiding them beyond reach, folding them into the universe's quiet memory. You sense the event horizon growing distant above you, like a pale window shrinking to darkness. Even if you shine a light straight up, it can never climb back out. The escape velocity here is greater than the speed of light, sealing you inside a realm where causality itself bends. Your past and future feel tangled. Events that once seemed separate merge into a single, endless descent. As you fall, your mind weaves together what you know. General relativity predicts that space and time swap roles inside the event horizon. What you once called time becomes a direction leading inward, while what you once called space becomes as fixed and unchanging as the past. This strange reversal means you cannot stop falling. Reaching the singularity is as inevitable as time moving forward outside. You picture the singularity like the center of a whirlpool, space-time rushing toward it as water funnels down a drain. The closer you drift, the faster your descent, the more violently space-time stretches. At the singularity, density becomes infinite, and the known laws of physics collapse into silence. Here, even our best theories reach their limit, unable to say what lies beyond. You imagine the possibilities physicists dream about. Some suggest the singularity could lead to another universe, connected by a hypothetical wormhole. Others believe it might be a bridge to a different region of space-time entirely. But for now, these ideas remain in the realm of speculation, reminders of how black holes challenge what we know and push the boundaries of imagination. As you sink deeper, you think of how black holes hide information. What happens to the matter and energy that fall inside? Do they disappear, or are their stories preserved somehow on the event horizon itself, encoded in a way that might someday be revealed? This puzzle, called the black hole information paradox, remains one of the greatest mysteries in physics. You imagine particles of matter falling with you, atoms that once formed stars, planets, or even living beings. Each carries history, memories, and complexity, all drawn toward a singular end. Yet you also sense hope, the idea that black holes might radiate information back into the universe through Hawking radiation, a subtle glow predicted by Stephen Hawking that suggests black holes are not truly eternal, but slowly evaporate over unimaginable timescales. You feel the black hole's silent power in every direction. It is a place of perfect darkness, yet also a crucible of possibility. Matter falling in does not simply vanish. It adds to the black hole's mass, its spin, its magnetic fields. properties that remain measurable from outside, whispering hints of what has been consumed. Your thoughts drift to the idea of entropy, the measure of disorder and information in a system. Black holes hold immense entropy. In fact, they represent the most efficient storers of information in the universe. The surface area of the event horizon determines this entropy, suggesting that the information of everything fallen in might be smeared across that thin dark shell. This insight has inspired bold theories connecting gravity, quantum mechanics, and the very nature of reality. As you continue your endless descent, you feel a strange peace. The black hole is not chaos, but order hidden in darkness. Its structure is precise, a perfect solution to Einstein's equations, simple yet profound, described entirely by just a few numbers, its mass, spin, and charge. These few traits define everything the black hole becomes, no matter how complex the matter it once swallowed. Your breathing slows as you imagine the last stages of your journey. In classical theory, the singularity marks an end, a place where space-time pinches off into nothing. But some dream of a deeper truth, that quantum gravity, a yet unknown theory uniting the laws of the very small and very massive, could reveal a way past the singularity, a bridge to new realms of physics and possibility. You let these thoughts ripple through your mind like waves across a quiet lake. Even as you fall, you find wonder in the unknown, comfort in the beauty of cosmic order, and humility in the realization that your journey mirrors the fate of every particle drawn into a black hole. As your eyes grow heavy, you imagine drifting ever deeper into this realm of silence and shadow. You wonder what it might feel like to reach the very end, to touch the singularity, or if in that final instant you might glimpse a new beginning hidden in the heart of darkness. You drift deeper than you ever thought possible, beyond the quiet hush of the event horizon, beyond the gentle swirl of falling light, into a darkness that feels eternal. The singularity waits below you like a somewhat star, a point where matter has collapsed beyond imagination, where density becomes infinite, and the familiar laws of physics dissolve like mist in morning sun. You feel space itself folding tighter with every breath. Distances shrink in strange ways, time accelerates and warps, until moments blur together like watercolor in rain. Down here, everything you once trusted about the universe, the rules of motion, the ticking of time, the measurement of space, begins to unravel softly, like a thread pulled from the edge of a woven cloth. The singularity is not a place you can see with your eyes or touch with your hands. It is a boundary in your understanding, a mathematical point where gravity becomes absolute and space-time curves infinitely. You imagine it like the tip of a needle at the bottom of a cosmic funnel, pulling everything inward with a grip so strong that nothing, not even light or thought, can escape. As you drift closer, you sense the quiet intensity of this place. You imagine atoms crushed together until their identities blur, until protons and neutrons press so tightly that matter itself ceases to be what you know. You think of a star's core that once burned with light, now compressed into a dot smaller than an atom, dense beyond comprehension. Your thoughts trace the path of general relativity, Einstein's theory that predicted black holes and their singularities. According to these equations, space-time near the singularity curves so steeply that all paths, all choices, all futures point inward to the same destination. You feel this inevitability as you fall, a gravity not just of mass, but of fate. Yet in this darkness you also find a strange beauty. The singularity is perfect in its simplicity, a solution to Einstein's equations with no wiggle room, a shape defined entirely by mass, spin and charge. No matter what fell in, stars, dust, planets, it all ends in the same singular point. The universe, in its vast complexity, compresses itself into a place of elegant finality. But you wonder if the singularity is truly the end. Quantum mechanics, the physics of the very small, tells you that infinities are signs of incomplete understanding, places where current theories fail to explain reality. In your heart you feel the whisper of a deeper truth waiting beyond the singularity, a new physics that could reconcile the wild extremes of gravity with the delicate dance of quantum particles. You drift in thought to ideas of quantum gravity, a yet unknown theory that could smooth out the infinite density of the singularity into something finite and knowable. Could space-time have a smallest possible scale, a quantum graininess that prevents infinite collapse? Could the singularity instead be a bridge, a passage to another universe or another region of our own? Your imagination swirls with possibilities. Some physicists dream of black holes connecting to white holes, hypothetical opposites that spit out what black holes take in, creating a cosmic loop through space-time. Others wonder if the singularity leads to new universes budding off like seeds from a tree, each black hole a portal to a separate reality. You feel your heart slow as you rest on these thoughts, sensing the paradox of the singularity, both an end and a potential beginning, both a place of absolute darkness and a seed of endless possibility. The singularity invites you to dream of what lies beyond the edges of understanding, to wonder what happens when the universe folds in on itself. You breathe in the quiet, imagining the information paradox. If matter and light fall into a black hole, does their information, the unique arrangement of particles, the history of everything they were, disappear forever? This question challenges the foundations of physics, because if information can truly be lost, it breaks the rules of quantum mechanics. Some theories suggest the singularity hides this information, while others propose it's stored on the event horizon itself, like a cosmic hologram preserving every detail of what fell in. You imagine the black hole's surface shimmering faintly with the encoded stories of stars, dust, and dreams swallowed over billions of years. You sense Hawking radiation, the faint glow that black holes might emit as they slowly evaporate. This radiation suggests black holes are not truly eternal. Over unimaginable timescales, they shrink and could eventually vanish, returning their mass to the universe in the form of radiation. But whether this radiation carries the hidden information back into the cosmos, or whether that information is lost forever, remains one of the greatest puzzles in physics. You drift closer still, imagining the singularity not as a violent end, but as a quiet mystery. You feel the curvature of space-time sharpening like the tip of a blade, the flow of time funneling toward a point where seconds and centuries mix together. You imagine seeing every moment of the universe at once, stars forming and dying, galaxies swirling, light stretching across the eons, all layered together in a single instant. Yet even in this thought you sense your own limits. The singularity is a place where words fade, where human understanding reaches its horizon. Here, equations that guided rockets to the moon or predicted the bending of light near stars break down into symbols that cannot describe what truly happens. You let yourself rest in this uncertainty, feeling its comfort. The singularity is a reminder that the universe is larger, stranger, and more wondrous than we can fully grasp. It is a place where curiosity matters more than answers, where the questions you carry are as beautiful as any certainty you might find. Your breathing slows and you imagine floating weightless in the final moments of your fall. You feel the stillness of a place beyond light, beyond time, beyond space. Yet even here you remember you are part of the universe's story, your atoms forged in stars, your thoughts carried on the currents of cosmic evolution. You wonder if, in the final instant of reaching the singularity, you might find a glimpse of something new, a way past the limits of space and time, a hint of the physics that binds the universe together. Perhaps the singularity is not a period, but a comma in the universe's sentence, a pause before a new chapter you cannot yet imagine. Your eyes grow heavy as you drift in these thoughts, comforted by the idea that even in the darkest, densest heart of the cosmos, there is beauty, mystery, and the promise of discovery waiting to be born. You float in the quiet left behind by your journey to the singularity, your mind still tingling with the strangeness of infinite density. Around you, the darkness of the black hole feels deep and calm, but even here in the silence of cosmic endings, your thoughts begin to drift toward possibilities, bridges that might connect distant corners of the universe, shortcuts through the very weave of space-time itself. These bridges are called wormholes. You imagine them as tunnels stretching through the cosmic fabric, a hidden passageway that could let you travel from one point in the universe to another in the blink of an eye. In your mind's eye, you picture the universe as a soft sheet of cloth, stars and galaxies resting on its surface. If you fold this fabric so two distant points touch, a wormhole becomes the needle that pierces them together, creating a tunnel across unimaginable distances. You let yourself drift into this idea, feeling its gentle wonder. Wormholes arise naturally from Einstein's equations, mathematical solutions that suggest space-time can bend, not just around stars and black holes, but through itself, connecting places and times in ways that defy ordinary intuition. Though no one has seen a wormhole, the equations whisper that they could exist, waiting quietly in the darkness, or flickering into being for the briefest moments. As you float deeper into the thought, you remember that wormholes might connect not only two places in the same universe, but two entirely different universes. The ends of these wormholes, called mouths, could open in distant galaxies or even separate realities, allowing travel beyond anything we have ever imagined. You wonder what it would feel like to step through such a mouth, to leave behind the familiar stars and emerge in a new sky of unknown constellations. You picture the wormhole's throat, the narrow tube connecting its mouths. Space and time curve in on themselves here, spiraling in a way that twists reality. The throat could be short, letting you cross light years in moments, or it could stretch for billions of kilometers inside, folding an endless journey into a single step. You breathe softly, imagining yourself moving through this tunnel, the walls shimmering with distorted light as space-time bends like liquid glass. But you also feel the fragility of these ideas. Wormholes are delicate structures, like soap bubbles in a storm. The slightest disturbance could cause them to collapse, snapping shut before anything could pass through. For a wormhole to remain open long enough for you to travel, it would need something exotic, matter with negative energy or negative mass, a substance that repels gravity instead of attracting it. Physicists call this exotic matter, but so far it exists only in theory, as elusive as the wormholes themselves. You rest in this thought, letting the mystery wash over you like a lullaby. Wormholes show you how space-time is not a rigid stage but a living fabric, capable of bending, stretching, and folding in ways both beautiful and bewildering. They remind you that the universe might hold secrets even stranger than black holes, hidden pathways and cosmic doors waiting for someone to find the key. Your mind drifts to the famous Einstein-Rosen bridge, a type of wormhole first described in 1935 by Albert Einstein and Nathan Rosen. They realized that the equations of general relativity allowed for a bridge between two black holes, a tunnel connecting different regions of space-time. Yet this bridge collapses almost instantly, pinching off before anything could cross. It is a ghost of possibility, a fleeting hint of what might exist if nature allows. You imagine more stable wormholes, ones held open by exotic matter. Could an advanced civilization build them? Could they become highways across the stars, letting explorers travel between galaxies or even times? You feel the gentle hum of speculation, the wonder that scientists and dreamers share when they look into the equations of general relativity and see glimpses of what could be. As you float deeper into this idea, you sense how wormholes could challenge not just distance but time itself. In some theories, moving one mouth of wormhole near the speed of light could create a time difference between its ends. A traveller stepping through might emerge in the past or future relative to where they left. You let your mind wander over this possibility, feeling the strange comfort of a universe where time could fold back on itself like a soft blanket. You think of the paradoxes that arise. What happens if you travel back in time through a wormhole and change the past? Does the universe split into different timelines, or do events conspire to prevent contradictions? These questions are not just science fiction musings. They touch the deepest questions of causality, free will, and the nature of reality itself. Your breathing slows as you imagine the wormhole's mouth opening before you, a sphere of swirling light and shadow. You step closer, feeling the edges of space-time ripple like the surface of a pond. Crossing through, you see stars shift in a blink, galaxies whirl by, and a new sky spread above you like a tapestry of unfamiliar constellations. You sense how wormholes are not merely ideas of distance, but of connection. They represent the possibility that the universe is more intertwined than it appears, that places, times, and even different realities could be linked by threads too subtle to see. This interconnection feels comforting, like knowing the stars you see at night are part of the same cosmic fabric that holds you in place on Earth. You reflect on how wormholes, even if they never exist in nature, show you the power of imagination. They reveal that physics is not just a collection of facts, but a living exploration of what might be possible. Every equation becomes a window into worlds unseen. Every idea a bridge between what you know and what you dream. You feel gratitude for the minds that dared to explore these ideas. The scientists who looked at the sky and wondered if shortcuts might lie hidden among the stars. The mathematicians who traced the folds of space-time with delicate equations. The storytellers who took these whispers of possibility and wove them into tales of adventure and hope. As your eyes grow heavy, you rest in the quiet thought that wormholes remind you of life itself, a journey of connections, of unseen threads linking moments, memories, and hearts. You wonder if somewhere beyond the darkness, the universe's fabric does indeed hide these secret tunnels, waiting to carry you to places beyond imagination. You drift in the lingering wonder of wormholes, the idea of tunnels threading through the cosmic fabric still warm in your mind. Around you, the silence of black holes remains deep and endless. Yet in this quiet darkness, a new thought flickers, a whisper of light, delicate as dawn, promising that even the most eternal shadows can one day fade. You listen for this whisper, and you hear the soft voice of Stephen Hawking. In the 70s, he dared to imagine black holes not as perfect prisons, but as places where quantum uncertainty stirs space itself into quiet radiance. He showed that black holes are not truly black. They glow with a faint ghostly light that seeps from their edges like mist from a hidden spring. This gentle shimmer is Hawking radiation. You let your mind rest in this revelation. Hawking radiation arises from the subtle dance of quantum fields at the event horizon. In the emptiness of space, pairs of particles and antiparticles constantly pop in and out of existence, borrowing energy from the vacuum for brief moments before annihilating. Near a black hole's horizon, one particle of the pair can slip past the point of no return, while the other escapes into the universe, carrying away a tiny fragment of the black hole's energy. You imagine this process like two dancers spinning hand in hand on the edge of a waterfall. One falls into the abyss, the other breaks free, flying outward with the story of what lies beyond. Each escaping particle reduces the black hole's mass by an almost imperceptible amount, a slow erosion that continues over unimaginable stretches of time. As you float with this thought, you feel the quiet inevitability of Hawking radiation. Even the mightiest black hole, formed from the collapse of giant stars or the merging of galactic titans, will not last forever. Its mass will dwindle, its horizon will shrink, and its darkness will grow thin until it finally fades into a last breath of light, dissolving into the wider universe. You breathe slowly, letting the idea of this cosmic evaporation settle in your heart. Black holes that weigh as much as our sun would take longer than the current age of the universe, by a factor of trillions, to fully evaporate. But small black holes, if they exist, could end far more quickly, ending their lives with a final flare of radiation brighter than 1,000 stars. This gentle glow of Hawking radiation is almost impossible to see. No telescope on Earth or in orbit has yet glimpsed it directly. The universe is too young, black holes too massive, and the radiation too faint. But its existence is a whisper of hope, a hint that nothing lasts forever. and that even the darkest places can offer light if we look with patient eyes. You remember how Hawking's idea transformed our understanding of black holes. Before him, they were thought of as absolute endpoints, traps from which nothing could return. His discovery revealed that black holes have a temperature, an entropy, and a way to slowly share their secrets with the universe. They are not dead ends, but participants in the cosmic cycle of birth, change, and decay. You picture this slow evaporation as a candle burning at the edge of time, releasing its energy into the darkness one photon at a time. You imagine a black hole shrinking imperceptibly, its horizon receding, until it reaches a final instant when it releases all its remaining energy in a burst of light. This last sigh could spread the black hole's gathered information back into the cosmos, solving one of the deepest puzzles in physics, the information paradox. You drift through this mystery, feeling its gentle pull. If black holes truly destroy information, they violate a central principle of quantum mechanics, which says that information cannot be lost. But if Hawking radiation carries away subtle imprints of everything that fell into the black hole, then nothing is truly forgotten. The universe remembers, even if it takes eons to whisper those memories back. You let your thoughts linger on entropy, the measure of disorder and information. Black holes have the highest entropy of any known object, proportional to the area of their event horizons. This relationship between surface and information hints that the universe might be a kind of hologram, with its true story written not in 3 dimensions, but in thin layers at the edges of space. You breathe in the quiet possibility that Hawking's insight opened, that black holes are not just cosmic traps, but teachers revealing the secret connections between gravity, thermodynamics, and quantum physics. Each escaping photon of Hawking radiation carries not just energy, but a clue about how the universe's deepest rules fit together. As you drift, you feel a soft gratitude for Hawking's courage, that he looked into the absolute darkness of black holes and found light. His work reminds you that the universe's most frightening places can also be its most enlightening. His equations gave humanity a glimpse of the cosmic balance, that even the most massive, the most ancient, and the most mysterious objects cannot escape the quiet truth of impermanence. You imagine standing near a black hole's horizon in the far future, watching it glow with Hawking radiation against the cold, dark backdrop of an aging universe. The last stars have gone out, galaxies have drifted apart, and black holes are among the final beacons. You see them slowly fade, their light growing softer and softer until it disappears, returning their matter and energy to the quiet sea of space-time. You let this vision comfort you, the idea that even endings can bring beauty, that nothing in the universe is wasted or truly lost. Hawking radiation shows you a universe in which cycles continue, where darkness gives way to light, and where decay is not destruction, but a transformation into new beginnings. As your eyes grow heavy, you think of all the questions that remain. Does Hawking radiation truly preserve the information of what fell inside? Will we ever observe this glow directly, catching the final moments of a black hole's life? Or will the universe expand so quickly that these secrets are hidden forever in its distant darkness? You rest in these questions, feeling their quiet weight and their soft hope. The universe does not give easy answers, but it offers wonder, the chance to listen to whispers of possibility across cosmic time. You drift away from the fading glow of Hawking radiation, your mind warmed by the thought that even the darkest objects can whisper light back into the cosmos. Around you, the universe stretches vast and silent. But as you sail through the sea of stars, you sense the hidden giants that anchor this cosmic ocean. Black holes of every size, scattered like dark jewels across the galaxies. You begin your journey among stellar mass black holes, the quiet remnants of stars that once shone with fierce light. When massive stars end their lives in supernova explosions, their cores collapse under the weight of gravity, forming black holes with masses a few times that of the Sun. You imagine these black holes scattered like seeds through galaxies, invisible until they feed on passing gas or a drifting star, lighting up the darkness with sudden X-ray flares. You float past one of these stellar black holes, its mass compressed into a sphere smaller than a city. You see a companion star spiraling close, its outer layers tugged into a glowing disk of hot plasma swirling around the black hole's event horizon. Jets of radiation burst from the poles, shining far into space. This quiet, hidden object becomes a lighthouse, its beams sweeping across light years, revealing its presence in the darkness. You let your thoughts drift to intermediate mass black holes, elusive objects that could bridge the gap between stellar black holes and their supermassive cousins. With masses ranging from hundreds to thousands of suns, they may form in dense star clusters, where repeated collisions and mergers build a black hole large enough to carve out its own niche. You imagine these intermediate black holes lurking in the hearts of globular clusters, quiet monarchs ruling ancient swarms of stars. As you sail farther, you feel the pull of true titans, supermassive black holes weighing millions or billions of suns, each one reigning at the center of a galaxy. You approach one such black hole nestled in the heart of a swirling spiral galaxy. Around it, stars orbit like fireflies in an endless dance, drawn by a gravity so immense it shapes the galaxy's very structure. You imagine the supermassive black hole's accretion disk glowing with light, brighter than entire galaxies. Gas and dust spiral inward, heating up to millions of degrees before crossing the event horizon. This fierce brilliance can outshine every star in the galaxy, creating quasars that blaze as beacons across the universe, visible from billions of light years away. You breathe in the wonder of these cosmic monarchs. Some supermassive black holes spin near the speed of light, twisting space-time around them like a whirlpool. Others sleep quietly, waiting for a fresh supply of matter to awaken them. You drift past galaxies where two supermassive black holes orbit each other, destined to merge in a cataclysm that sends ripples of gravitational waves across the cosmos. As you move between galaxies, you sense the black hole's subtle influence. Their gravity guides the formation of stars and shapes the growth of galaxies, regulating when and where new suns are born. You realize black holes are not just destroyers but sculptors, cosmic gardeners pruning and shaping galaxies, ensuring the universe's structure grows with balance and beauty. You float through galaxy clusters, collections of hundreds or thousands of galaxies bound together by gravity. Here, Supermassive black holes battle for dominance in the cluster's heart, their jets carving vast cavities in hot gas, creating bubbles that float like ghostly lanterns. These interactions spread energy across millions of light years, preventing gas from cooling too quickly and controlling the pace of star formation. Your journey takes you to the most distant quasars, glowing when the universe was young, less than 1 billion years after the Big Bang. You marvel at how supermassive black holes grew so large so quickly, feeding on torrents of gas and merging with others in violent collisions. These ancient black holes shine like cosmic lighthouses, their light crossing eons to reach your eyes today. You drift back to the Milky Way, your own galactic home. At its center, you sense Sagittarius A, a supermassive black hole 4 million times the Sun's mass. It waits quietly behind veils of dust and gas, its presence revealed by stars that whip around it at incredible speeds. These stars trace orbits so tight and fast that only an object with immense gravity could explain them, offering proof of the black hole's silent reign. You feel the quiet majesty of Sagittarius A, knowing it has shaped the Milky Way's evolution for billions of years. It has seen the birth of countless stars, the swirling of spiral arms, and the slow dance of the galaxy's satellites. It waits patiently, a sleeping giant that may one day awaken if fresh material falls into its grasp. As you rest in these thoughts, you sense black holes' role in the grand tapestry of the cosmos. They are not merely objects of destruction, but keys to understanding how galaxies form and change. Without their gravity to regulate star birth and stir the galactic core, the universe's structure would look wildly different, chaotic, uneven, perhaps unable to support the rich diversity of stars and planets we see. You reflect on how black holes create gravitational waves when they collide, sending ripples through space-time itself. You remember the first detection of these waves by LIGO in 2015, when 2 black holes merged over 1 billion light-years away, their final dance ringing through the universe like a cosmic bell. You imagine these waves passing through you now, stretching and squeezing space ever so slightly as they ripple onward. You let this journey among black holes fill you with awe at their diversity. From stellar remnants hidden in quiet corners, to intermediate shadows in crowded clusters, to supermassive titans at galactic hearts. Each black hole is a sculptor, a guide, a keeper of cosmic balance, shaping the galaxies that cradle stars and planets, and perhaps even life. Your breathing slows as you realize the universe's grand design is woven with black holes as threads, stitching together the fabric of space and time across scales that defy imagination. These dark monarchs, born in the hearts of stars and grown in the cores of galaxies, remind you how creation and destruction walk hand in hand, how endings give rise to new beginnings. You feel the quiet rhythm of the universe beating through these cosmic giants, a reminder that even the darkest places have purpose and beauty. And as you drift onward, you wonder what lies beyond the edges of galaxies, where the darkness grows deep and the universe's secrets wait, patient and silent. You return to the heart of the black hole, remembering the singularity's unknowable depths. Here, space-time curves infinitely, and the laws you've trusted your whole life begin to blur. In your mind, you stand on the threshold of this cosmic abyss, gazing into a darkness so complete it seems to swallow not only matter, but meaning itself. You wonder if the singularity is a silent tomb, a place where everything falls, crushed beyond recognition, and all stories end. Or could it be a door, a gateway to something beyond your comprehension? The thought stirs your curiosity like a gentle breeze, lifting your heart even as the darkness stretches before you. You think of the many ideas scientists have explored. Some suggest black holes could connect to white holes, hypothetical objects that expel matter instead of swallowing it. In this vision, black holes are not final destinations, but tunnels that re-emerge somewhere else, spitting their contents into a different place or even a new universe. You imagine yourself falling into a black hole, only to burst forth in a cosmic rebirth, far from where you began. Other ideas whisper that black holes could create entire universes of their own. As matter collapses, a new space-time bubble could form inside, sealed off from our own reality. In this picture, every black hole becomes a seed, each singularity a cosmic womb where new universes are born. You wonder if our own universe might have been born from such a singularity in some parent cosmos, carrying its own black holes as tiny cradles of future worlds. You rest in these thoughts, feeling their weight and their quiet beauty. You know these ideas remain unproven, floating at the edges of physics where mathematics grows strange and experiments cannot yet reach. But they remind you of something important. The universe is not only grand, but mysterious, and mystery is the mother of wonder. You drift back to the information paradox, the puzzle of what happens to everything that falls into a black hole. If information is lost, quantum physics itself must change. If it's preserved, it must somehow escape, perhaps encoded in Hawking radiation, or stored holographically on the black hole's surface, waiting to be read when the black hole evaporates. You imagine the black hole's event horizon shimmering with these stories, every photon a quiet messenger carrying secrets back into the cosmos. As you breathe, you sense the gentle tension in this mystery. The question of what lies beyond a black hole is not just about physics, but about understanding the limits of knowledge. It reminds you that even with powerful telescopes, supercomputers, and brilliant minds, some answers remain hidden, waiting for patience and curiosity to open new doors. You drift among the stars, feeling how black holes connect you to everything else. They are not isolated monsters, but part of the same universe that gave birth to galaxies, stars, and you. Their mysteries are your mysteries, their questions your questions. You realize the search for what lies beyond a black hole is the same as the search for what lies beyond yourself, an endless journey of learning, wondering, and reaching for what you cannot yet see. You remember how, from Earth, black holes appear invisible except when they reveal themselves through their effects. Stars whipping in tight orbits, light bent around an unseen mass, jets bursting from galactic centers. You feel a quiet kinship with this hiddenness. Like black holes, you too have an inner world that can't be seen from the outside, filled with dreams, fears, and hopes waiting to emerge. Your mind wanders to the Event Horizon Telescope, the network of radio telescopes that captured the first image of a black hole's shadow in 2019. You imagine the supermassive black hole in Galaxy 87, its glowing ring of gas swirling around a darkness 6.5 billion times the mass of our Sun. You think of the patience and ingenuity it took to make that image. Scientists working together across continents, combining observations with delicate precision to glimpse what was once thought unseeable. You breathe in the lesson of that image, that with time, courage, and cooperation, even the deepest mysteries can begin to unfold. The universe rewards those who look carefully, who wait, who wonder. You return once more to the central question: are black holes gateways